Hello students, welcome to aimstoday online classes. This is a chemistry session. Here we are discussing about different types of chemical reactions. In this session we are going to see about redox reactions. Okay, what are redox reactions? And let us see some examples for these. Redox reactions are those reactions in which simultaneous oxidation and reduction reactions takes place. Such kind of reactions are called redox reactions. What are those? The chemical reactions in which both oxidation and reduction takes place simultaneously are called redox reactions. Redox reactions are everywhere in our daily life. We observe them often. Our body uses redox reactions to convert food and oxygen to energy, water, and carbon dioxide. Of course, out of this, carbon dioxide gas is exhaled out. So here, in the conversion of this food which we have taken into energy and water and carbon dioxide is utilizing their redox reactions. And even the batteries in our electronic goods, they also rely on redox reactions. We're able to utilize various types of fuels because of oxidation. So oxidation of fuels help in producing energy, isn't it? In our daily life, we are using so many kinds of fuels for different purposes. So these all fuels, they are producing energy. That energy we are using for our works. So here, these fuels are producing energy by the process called oxidation. Okay, in this way, these oxidations, reductions, and even redox reactions we observe in our daily life also. Now let us see what are these oxidations and reductions. Let us see in detail. First, let us go through the oxidation reactions. So the oxidation reactions are two types basically. Based upon the type of reaction occurring there, these oxidation reactions can be classified into two types. One among them is addition of oxygen to a chemical substance is called oxidation. In the other way, it also can be defined as removal of hydrogens from a compound, from a substance, also called as oxidation. Okay, oxidation can be defined as now addition of oxygen or removal of hydrogen from a chemical substance is known as oxidation reaction. Let us see these two with simple examples. First, let us go through the addition of oxygen. So the addition of oxygen to a chemical substance is called oxidation. That substance is said to be oxidized. For example, if you see here, hydrogen is added with oxygen to form water. What is happening here? Hydrogen is added with oxygen. This addition of oxygen to a chemical substance is called oxidation. Now we can say here hydrogen is oxidized because hydrogen is added with oxygen for the formation of water. So we can say hydrogen is oxidized to form water. The same oxidation can be defined in the other way also. It can be defined as removal of hydrogens from a chemical substance. Let us see an example for that. That is for removal of hydrogen. If we say hydrogen sulfide H2S is added with iodine to form hydrogen iodide and sulfur. If we observe in this reaction from the hydrogen sulfide, hydrogen is removed and sulfur is remained finally. So what we can say here, hydrogen sulfide is oxidized because hydrogens are removed from hydrogen sulfide substance. So the removal of hydrogens is called oxidation. Either addition of oxygen or removal of hydrogen is called as oxidation. So we can say here hydrogen sulfide is oxidized because hydrogen atoms are removed from that molecules of hydrogen sulfide. Finally, sulfur is left back, isn't it? So this is called oxidation. Okay, of course there are some other definitions also. Basic definitions are these two. Either addition of oxygen or removal of hydrogen can be termed as oxidation. Let us another kind of reaction, that is reduction. Just like oxidation, reduction also can be defined in two ways, in terms of oxygens and even in terms of hydrogens also. If we say in terms of hydrogens, the addition of hydrogens to a chemical substance is called reduction. In terms of oxygens, the removal of oxygens from a chemical substance can be termed as reduction. Now let us see example for this in terms of both. First, if we take in terms of hydrogens, we told the addition of hydrogen to a chemical substance is called reduction of that substance. Just now you have seen this example, hydrogen sulfide plus iodine gives hydrogen iodide plus sulfur. In the earlier example we explained about oxidation of hydrogen sulfide, isn't it? Because from the hydrogen sulfide, hydrogens are removed and it finally became sulfur. So he said there, hydrogen sulfide is oxidized because hydrogens are removed. If you see the same reaction in terms of iodine, initially iodine is alone with only iodine atoms, but after the reaction, it is added with the hydrogen atoms. So hydrogen is added to it. The addition of hydrogens is said to be reduction. So here we can say iodine is reduced in this reaction. Iodine is reduced to hydrogen iodide. Okay, in this way, addition of hydrogens is said to be reduction. The same reduction can be defined in terms of oxygens also. That is removal of oxygens. Let us see an example for that. For the removal of oxygens. If you see an example equation, zinc oxide plus carbon gives zinc plus carbon monoxide. In this reaction, if you see, initially zinc oxide contains zinc with oxygens. But after the reaction, if you observe, oxygens are removed from zinc oxide, it remained as zinc, isn't it? So what happened here? Zinc oxide lost its oxygens. That loss of oxygens is said to be reduction. Now we can say here zinc oxide is reduced. If we say in terms of carbon, carbon is oxidized because oxygens are added to carbon to convert into carbon monoxide, isn't it? So carbon is oxidized, zinc oxide is reduced. In this reaction also you can say both. Hydrogen sulfide is oxidized whereas iodine is reduced. Okay, these are oxidation and reduction reactions in terms of oxygens and hydrogens. Now let us see once again what is meant by redox reaction. The chemical reactions in which both oxidation and reduction taking place simultaneously are called redox reactions. So in certain chemical reactions, the chemicals they combine. While reacting there, if one substance is oxidized and another substance is reduced simultaneously, then that reaction is said to be redox reaction. Red ox, red representing their reduction, ox representing oxidation. If both reduction and oxidation occurring simultaneously in a chemical reaction, then that reaction is said to be redox reaction. Okay, now let us see two more different terms from this. One it is oxidizing agent and other one is reducing agent. Here oxidizing agent means it is a compound or the compounds which can add oxygens or which can remove hydrogens from a chemical substance are known as oxidizing agents. To say in definitional, compounds which can add oxygen or non-metallic compound or which can remove hydrogen or metallic elements from a substance are called oxidizing agents. In the same way, reducing agents, the compounds or elements which can cause reduction are called reducing agents. How they can cause a reduction? So this also can be told the chemical substances which can remove oxygens or which can add hydrogens to a chemical substance so that that substance will be undergone reduction. So those substances which are helping in that reduction, either by removing oxygens or by adding hydrogens to the substance, are called reducing agents. Oxidizing agents means the chemical substances which are helping for the oxidation of some other substance, either by adding oxygen to that or by removing hydrogen from the substance, are called oxidizing agents. Okay. Now let us see some example for these definitions to understand in clear. For example, when copper oxide is heated with hydrogen, then copper metal and water are formed. See here, equation is shown for this reaction. When copper oxide is heated in presence of hydrogen, it forms a copper metal and water as products. Now in this reaction, let us see which is getting oxidation and which is getting reduction. So in this reaction, copper oxide is changing into copper. So what is happening here for the copper oxide? Copper oxide is losing oxygens to form pure copper metal. That loss of oxygens is called reduction. So we can say copper oxide is being reduced in this reaction. Copper oxide is reduced to copper. If you see in terms of hydrogen, hydrogen initially does not contain any oxygens in it, isn't it? So after the reaction, what is happening here? Hydrogen is changing into water, means it is added with oxygens. So the addition of oxygens we know as it is called oxidation. Now we can say hydrogen is oxidized to water. Hydrogen is oxidized, copper oxide is reduced. Okay. In the same reaction, we can say copper oxide is giving its oxygen to hydrogen and helping in the oxidation of hydrogen. So copper oxide is helping for the oxidation of hydrogen by giving its hydrogen to it, isn't it? Therefore, copper oxide is called helper of oxidation, that we say oxidizing agent. So here copper oxide is oxidizing agent which is undergone reduction. If you see in terms of hydrogen, hydrogen is taking hydrogen from copper oxide. Sorry, it is taking oxygens from copper oxide and helping in the reduction of copper oxide. So hydrogen is helping for the reduction of copper oxide by taking its oxygen. So we can say this hydrogen as here helper of reduction, that is meant by reducing agent. So hydrogen is a reducing agent, copper oxide is a oxidizing agent. See, the action it is undergoing and its activity, both are quite opposite here, that we have to understand. Copper oxide is undergone reduction and its behavior here it is oxidizing agent. Whereas if you see hydrogen, it is said to be here undergone oxidation and its activity is acting as reducing agent. Okay, that's about oxidizing agent and reducing agent. Let us see one more example now to understand this in detail. See this equation, magnesium plus lead oxide gives magnesium oxide plus lead. In this reaction, if you see in terms of magnesium, initially magnesium has no oxygens. So after the reaction with lead oxide, it gained oxygens. We know the gaining of oxygens is called oxidation. So we can say here magnesium is oxidized to magnesium oxide because it gained oxygens. If we see in terms of lead oxide, initially lead is with certain oxygens, but after the reaction it lost its oxygens. So we know the loss of oxygens is called reduction. Now we can say lead oxide is reduced to lead. Magnesium is oxidized to magnesium oxide. Lead is reduced to lead. Lead oxide is reduced to lead by the loss of oxygens. So the same reaction in terms of reducing and oxidizing agents also we can say. If we see the same lead oxide, it is giving its oxygen to magnesium. so that it is helping for the oxidation of magnesium. So we can say lead oxide is a oxidizing agent in this reaction, which is undergoing reduction, and it is helping for the oxidation of magnesium. So magnesium oxide is called here oxidizing agent because it is giving its oxygens to magnesium and helping for the oxidation of magnesium. That's why lead oxide is here oxidizing agent. In the same way, if you see magnesium, it is taking oxygen from lead oxide and helping for the reduction of lead oxide. So magnesium is a reducing helper, which can be called as reducing agent, which itself it is undergoing oxidation and helping for the reduction of lead oxide. So it is called reducing agent. Okay, the reaction which is it is undergoing and its action both are quite opposite in a way. So if magnesium is undergoing oxidation and it is helper of reduction, whereas lead oxide is undergoing a reduction and it is oxidizing agent. Did you get it? Next, now let us see the effects of these oxidation reactions in our daily life. Where do we observe these oxidation and reduction reactions, and what are the effects of these oxidation reactions? Many oxidation reactions take place in our daily life. Some of them are useful to us, while some of them are harmful to us. The two such common oxidation reactions are, one it is corrosion. It is the degradation of metals due to their reaction with oxygen. Generally, metals when they are kept outside for longer time, slowly they react with the oxygen. That reaction of metals with oxygen is called corrosion. Okay, one more oxidation reaction is rusting. It is also a common type of corrosion. It is formed when iron comes in contact with moist air. We have studied in the earlier classes also about this rusting of iron. What happens there? When iron particles are kept in the open air for few days, they slowly react with the atmospheric oxygen in the presence of moisture, and thus they form iron oxide, which we call commonly as rust. That is process is called rusting. As a result of corrosion, a reddish brown layer of ferric oxide is formed, which we call commonly rust. So this iron on reaction with the atmospheric oxygen in the presence of moisture forms iron oxide, which we call as ferric oxide. This is a brownish in reddish brown color. It forms a thick layer on the iron particles. That is called rust. So this is the equation related to that rusting process. So if you take pure iron, if it is kept outside, slowly that reacts with atmospheric oxygen in the presence of moisture or water vapor, and finally it converts into hydrated ferric oxide, which we call as rust. Hydrated ferric oxide is called rust. Here the variable n represents number of water molecules, may vary from condition to condition. Okay, this is rust. This is one of the oxidation process because iron is being added here with oxygen atoms. Say initially iron is there in the free form. It is combining with oxygen forming iron oxide. So gaining of oxygens is happening. That process is called oxidation. So rusting is one of the forms of oxidation process. Copper particles when left out in moist air get coated with a green layer. This is another example of corrosion where copper gets coated with basic copper carbonate. Okay, when copper particles are kept outside, they slowly react with atmospheric air and forms copper carbonate. Okay, this appears like a green color layer on the copper particles. So this is also one of the examples for oxidation of metals. So what are the effects of this corrosion? What happens if metals they undergo corrosion? What is affected by this? When metals undergo corrosion, it makes them weaken. So this corrosion weakens the metals and makes them brittle and reduces their tensile strength. We observe often in buildings certain metallic rods will be rusted. So they spoil the entire building construction there because by corrosion these metallic rods will be weakened and their tensile strength will be reduced. That becomes brittle and they may break very easily. So that is a bad effect of corrosion. So one more oxidation process is rancidity. So often the food cooked changed in taste if kept open for a long time. This is because of the fats get oxidized and hence are degraded with the time and start emitting bad smell. This process is called rancidity. So the oxidation of oils and fats present in the foodstuff resulting into a bad odor and a taste is called rancidity. So that is a oxidation of these fats causes rancidity of food items. So how can we control this rancidity? That we say as methods to prevent rancidity. One of them is food should be kept in airtight containers to prevent its oxidation. So if we keep the food stuff in airtight containers, so they won't be in contact with the air and hence we can stop the oxidation of those food stuffs. And one more method is nitrogen gas can be flushed while packing foodstuffs like chips, namkeen, etc. So we observe these foodstuff packets like chips. They'll be very fluffy. They filled with the air. Actually, they are filled with nitrogen gas. So this nitrogen gas won't allow the oxidation of these foodstuffs. That is why food will be fresh for a long time. Okay. One more it is by adding antioxidants to food stuff, we can reduce the oxidation of food. We can avoid the oxidation of foods by adding on antioxidants chemicals to them. So by these all procedures, we can prevent the rancidity of foodstuffs. We can avoid spoiling of those. Okay, that's about oxidation and rancidity. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.